Hi, now we will be beginning with the hardware simulation. So we will open our software, hardwaresimulator.bat. So this is our software. Now we will load our chip. So that's and.htl for the first program. And then we are going to, load our test file. So now the test file and the program is ready. Now we are simply going to run this. And this will go through the program and check whether everything is correct or not. Yeah, so now finally we can see our output. So this is our output. So as we can clearly see, for 0, 0, the output is 1. For 0, 1, the output is 0. For 1, 0, the output is 0. And for 1, 1, the output is 1, which is exactly what the AND gate does. This is our program for the AND gate. So I have written the code for AND gate myself. And then finally, we have got the output. So we have two pins here, A and B, and three pins here, A and B, and we have gates attached to that pin. That is the AND gate, and finally we get the value. And we can also text for custom input. For example, if we put a 0 here, so A is 0 and B is 1, and then we evaluate it, then the answer is 0 because for one high value and one low value, AND gate gives us the low output. So this is one program. Now we can run another program, the second one, demux, load chip. And then for this, we will load the script, demux. This is our demux, we will run it. Yes. So our demux has successfully run and we can just check the output. So this is our output. For input 0, 0 and 0, we get the output 0. For 0, 1, 0, we get 0. For 1, 0, 1, we get 0. For 1, 1, 0, we get 1. So which is the correct output. We can also check for custom value. For example, I'll check for 0 and 1 and then click on evaluate. And then the answer for A and B for both is 0, 0. So this is our demux and the demux works perfectly fine. Then we can check demux 4-way, demux 8-way, any program we would like to check. We will go through them one by one. Now the demux 4-way load chip, and then we will load the script. The script is loaded and now we will run. This is the code for demux 4-way. Yes. So demux 4-way has ran successfully. I'm going to open the output. So this is my output for demux 4-way. I can also check for custom output. I'll put the in value as 0 and the cell value as 3. So the answer will be A, B, C, D will be 0, 0, 0. Yeah. Now I will test the same output for demux 8-way, which will work the same way. Demux 8-way, load chip. And then I'm going to load the script, demux 8-way load script. I'm going to execute this. It will bring in the execution. Yeah, so it has completed execution. I'll go on view, then output. So this is my output for demux 8-way. I can also check for custom input. Now I'll open another chip. I'll write mux. I'll load mux, and then I will load the script for mux, mux.tst, and then run this. Yeah, so now I'm going to open the output. Sorry, output. So this is my output. As you can see, the output is like this. I'll just verify the last two outputs. So the last two outputs are 0, 1 and 1, 1. When I'm going to change the view to compare, I can see the correct output is 0, 1, 1, 1. So obviously our code is correct. This is the code for mux. Now the next program, not gate. And then the script, not. So this is my not program. Uh, it's very simple. Whatever we input, we just invert inverses. So I'm going to run this program. Okay, the execution is finished. Now I can just open the output. So whenever I input 0, the output is 1. When I input 1, the output is 0. So this is a very simple program. Now the next one, or load chip, run. Oh, sorry, I forgot to add the script, or load script. I'm going to execute. It has finished execution. I'll just open my view output. So this is my output. So for 0, 0, the value will be 0. For 0, 1, 1. For 1, 0, 1, and 1, 1, 1. Because even if one input is high, then the answer will be high, as I discussed in when we discussed about the OR logic gate. Now finally the XOR load chip, load script. I'm going to execute this. I can check my output. Yeah. So for whenever we have odd number of high inputs, the answer will be high. So in this case, for the first input, there is no high value. That's why the output is 0. For the second one, we have one high value, and similarly for the third one as well, because these are odd values, the output will be high. Finally, in the last one, we have two high values, which is even. That's why the output is low. So this is how we hardware simulated our program. Now coming back to the PPT. So this was the whole project one. We learned how to simulate NAND, NOT, AND, OR, XOR, MUX, DMUX gates, and we have different varieties of these gates as well. So this was all in project one of NAND to Tetris. We are going to learn a lot about in the coming assignments and videos. Thank you.